Center of mass. So today we will see center of mass. What is center of mass? What is the role of center of mass? So let us start with the beginning. So center of mass. So have you ever thought that why there are four legs in the table and those four legs are situated near the corner? Why can't it be somewhere else? Maybe somewhere here or here or here. So answer to all those questions can be found in this chapter. So what is center of mass? Suppose there is a large body. So we can assume that the center of mass of this large body is concentrated at one point, maybe here. So or we can say that any large body can be replaced by a single point, and we can assume that the mass of that whole large body is concentrated at that point. And this point can lie on the body or outside the body. So this is any large mass. So for this body, center of mass can lie somewhere here, which is outside the body. Suppose this is any circular disc, then center of mass will lie somewhere here. So we can say that center of mass is a point representing a large body where we can assume that entire mass is concentrated on that body. So basically this is center of mass. Now let us define center of mass. So center of mass, basically it is a point representing large body so suppose this is a large body, so we can replace this large body by a single point here. So meaning of this line is this: we can replace that large body by a single point. Now it is a point representing large body it is a point representing large body where entire mass can be assumed to be concentrated. And if any force is applied on it, then it will have same same translational same transitional motion as that of the body. That means, suppose this is the large body. If you are applying force here, let us say we are applying force F, then it will move in this direction, it will have acceleration in this direction. Then if we replace this large body of, let us say, mass m by its center of mass, that means what is center of mass? Center of mass is the point which is assumed, center of mass is the point which is assumed to be concentrated entire mass on this point. So here we replace this body by a small point m, and if we apply force on that point, then it will be having same acceleration as here. That means we can replace this whole large mass by a single point, and then we can analyze its dynamics. So next is, this center of mass can be real, it can be real point or imaginary. It means that suppose this is one mass and this is another mass, something like this. So for this, center of mass will be lying on the mass itself. For this object, center of mass will be lying somewhere here. So this point can be real if the center of mass is lying on the object itself, and if it is imaginary, that means that center of mass is not lying on the object, it is outside the object. Outside the object. So this is the meaning of that statement. It can be real or imaginary. Now let us define mass moment. Now what is mass moment? Mass moment is nothing but it is the product of mass and its cohesion vector. So m r, that means if here is one mass m and the cohesion vector of this is r, then if we multiply these two, then that will give mass moment. So this is the mass moment. So it is vector quantity. Its vector quantity. Its unit is kg meter. Its dimension is ml. So let us see the mathematical definition of center of mass. So let us take xy coordinate axis, and this is the z axis. So let us say there are so many masses like m1, m2, m3, and so on. So up to mn, and the cohesion vector of this m1 is R1, position vector of this M2 is R2, position vector of this M3 is R3, and so on. Position vector of this mass Mn is Rn. So these are the position vector. Then position vector of center of mass can be written as R center of mass. So it will be mass 1 multiplied by position vector of mass 1 plus M2 multiplied by position vector of M2 plus mass 3 into position vector of mass 3 plus, and so on, divided by M1 plus M2 plus M3 plus so on. So we can write this as summation of mass moment of all the masses divided by summation of all the mass. So this is the position of center of mass. So our center of mass. If you want to find individually the x center of mass, then it will be x center of mass. It will be mi xi divided by mi. That means x coordinate. This is xi is the x coordinate of mi. So this is the center of mass. We need to take the summation. Similarly, y center of mass is summation of mi into yi. That means y multiply the mass by the y coordinate divided by mi. Similarly, z center of mass is summation of mi zi divided by summation of mi. So let us take the example. So let us say there are three mass. Mass 1, let us say it is 1 kg and its position is 1,1,1. Mass 2, let us say it is 2 kg and its position vector or position is 1,0,2. Mass 3, is, let us say, 3 kg and its position is 0,2,0. So we want to find the position of center of mass of these three masses. So let us write the formula. R center of mass, it is M1 R1 plus M2 R2 plus M3 R3 divided by M1 plus M2 plus M3. So let us put the value. So here R1 is I cap plus j cap plus k cap, and R2 is I cap plus k cap, and R3 is 2 j cap. So let us solve this. So M1 is 1 into I cap plus j cap plus k cap plus M2. M2 is here 2 kg. 2 into I cap plus k cap. 2 into I cap plus k cap plus M3. M3 is here 3 kg and R3 is 2 j cap. 3 into j cap whole divided by 1 plus 2 plus 3. So this I cap plus j cap plus k cap, 2 I cap plus 2 k cap plus 3 j cap. Let us simplify. So I cap plus j cap plus k cap plus 2 I cap plus 2 k cap plus 3 j cap divided by 6. Let us simplify further. I cap plus 2 I cap, that means 3 I cap plus j cap plus j cap, that means 3 j cap plus 2 plus 3, that means 5 j cap. The 2 okay, so here it is j cap plus 3 j cap, so it is 4 j cap, k cap plus k cap, that means this is k cap and this is k cap, so it is 3 k cap divided by 6. So if we simplify, it is 1 upon 2 I cap plus 2 upon 3 j cap plus 1 upon 2 k cap. So the center of mass is 1 upon 2 I cap plus 2 upon 3 j cap plus 1 upon 2 k cap. 1 upon 2 I cap plus 2 upon 3 j cap plus 1 upon 2 k cap. So we can say that this is the coordinate 2 upon 3 upon 1 upon 2. So this is the center of mass, and this is how we find the center of mass. So let us take another example. Let us say one mass is here 4 kg and another mass is, let us say, 2 kg. It is kept at a distance of, let us say, 10 meter. Now we want to find the center of mass. Now for 2-point mass system, we will assume coordinate system such a way that one mass will be taken as origin so that it will be easier for us to calculate. So let us say that this is our origin of coordinate system and this is our x-axis. In this direction is our y-axis. In this direction is our z-axis. So here we can see that coordinate of 2 kg is 10, 0, 0. Then 4 kg is having 0, 0, 0. That means we need to deal with only x center of mass. Because y center of mass, coordinate of z center of mass is 0. So this will be 4 into 0 plus 2 into 10 divided by 4 plus 2. So this is 20 upon 6. So this is 10 upon 3. So center of mass will be somewhere here. So coordinate is 10 upon 3, comma 0, comma 0. So this is the center of mass of two mass system. So that means if this is M1, if this is M2, and this distance is B, then we can write center of mass of this system is X center of mass will be, let us assume this as origin, then coordinate of this will be D, comma 0, comma 0. So it will be M1 into 0 plus M2 into D divided by M1 plus M2. That means M2D upon M1 plus M2. And Y center of mass will be 0 and Z center of mass will be 0. So we can directly use this formula M2D upon M1 plus M2 for finding center of mass of two mass system. Here one more thing. So it is M2D upon M1 plus M2. So this was the center of mass. So that means what? That means center of mass will be lying between the point mass. So it will lie somewhere on this line. Now, if M2 is heavier, then center of mass will be lying near the M2. If M1 is heavier, then center of mass will be lying near the M1. So let us see this by example. So let us say this is 1 kg and let us say this is 2 kg. And let us find the center of mass. And the distance between these two is, let us say, 6 meter. So X center of mass will be, if we take this as origin, then coordinate of this will be 6, 0, 0. So it will be 1 into 0 plus 6 into 2 divided by 1 plus 2. That means 12 divided by 3, that means 4. So center of mass is somewhere here. This is the center of mass. So here this side is heavier, or 2 kg is heavy than this first mass. That means center of mass is shifting towards the 2 kg. Now, if situation was something like this, if this is 2 kg and if this is 1 kg, and we want to find the center of mass, that means center of mass will be somewhere here near 2 kg. And it will be how much? It will be 2 meters. Why? Because previously we got the center of mass is at 4. From here it is 4 meters. So from here it will be 2 meter. Now I have just reversed the position of 2 kg and 1 kg. So now center of mass is near 2 kg and which was away how much? 2 meter away from the 2 kg. So it is 2 meter away from the 2 kg. So this is the point to be noted that center of mass will be near the heavier object or two mass system. Or two mass system. Center of mass will be near to heavier object. Now what will happen if the mass of two bodies are equal? In that case, center of mass will be at midpoint. X center of mass formula is for two mass system m1 x1 plus m2 x2 divided by m1 plus m2. So if you put m1 equal to m2 equal to m and x1 equal to 0 and x2 equal to d, that means here is one mass m, here is one mass m, and the distance between these two is d. I am taking for the case when two objects are having same mass. So that means we can put the value here in this formula. Then we will get x center of mass will be m into 0 plus m into d divided by m plus m. That means md upon 2m. That means d upon 2. It means the exactly at the midpoint. Let us say this is the midpoint. So center of mass will be here. When the mass of both objects are same. So this is the center of mass. So we will conclude this lecture here, and next lecture we will see further